Helen from the Royal Astronomical Society, and I'm here at NAM 2019. So I'm here with Heidi Thiemann, who's created this amazing poster. So Heidi, can you tell me a little bit about it, please?
Yes, so I've been working with variable stars, so I'm looking at the relationship between how fast a star spins and how much X-ray light it gives out. So in general, if a star spins faster, it will give out more X-ray light. Obviously it's a bit different at the very, very fast ends and the very, very slow ends of the stars, but that's the general trend.
Wow, okay, and so what have you found out about that in real terms? Have you got any real results from this that people can sort of visualize and understand?
So I do have some real results, and obviously some are behind, but I want to tell you about something really interesting which has actually come out of this accidentally. So we've been looking through about 40,000 light curves of stars. So I've been going through them by hand, and we've actually identified some very interesting objects. So these are binary star systems, and usually this type of binary star system will have two stars orbiting one another, maybe a larger one and a smaller one, and they orbit each other, and their period of orbit going around each other will be about a day or less than a day. But we found about 20 systems which seem to have these orbital periods going around each other of between about 4 and 40 days. And this is really interesting because it means these might be red huge giant binary stars going around one another. So at the moment I'm going to be trying to identify whether this is real, and I'm taking photometrics, so data that you can see with your eyes, and spectroscopic data, so looking at the chemical components of the stars and work out whether this is real and whether this is a true exciting result.
So two red giant binaries, is that right?
Yeah.
I've never heard of that before. Is this the first time that we've seen something like this?
Yeah, so binary star systems usually tend to have a large and a small component, but having two giant stars of equal size, especially two red giant binaries, is not heard of. So we identified the first one in September of 2018, and we're following up, and so we're doing a campaign of follow-ups. And if it is true, and if these are real, we believe they could be progenitors or the original components of a red nova. And a red nova is a bit like a supernova, but smaller, redder, very dusty. And if we have two red giant binaries orbiting and coalescing and mass transfer happens and they explode and bash into each other, you get this red nova, and that would be really exciting to find.
Wow, so at the moment, are they quite close together? Would you'd imagine that star stuff would flow between them, is that right?
Yeah, you end up with mass transfer between these two, we end up with mass transfer between two binary stars, and because they're similar sizes, you might not end up with the same sort of mass transfer between a large and a small star, but there'll be still be star stuff flowing between them.
That's amazing, and part of this has been citizen science, is that right? So you've had a lot of amateur scientists looking at these light curves, is that what's happened?
Yeah, we have about 1.6 million light curves on a project called Zooniverse. And the public can actually go to the Zooniverse project and look at light curves and classify them as maybe a binary star system or a rotational star system or a pulsator, and we use their data and their responses to inform our real science.
So any member of the public presumably can sign in to look at this data, and they might be the person that discovers some of these things that have never been discovered before.
Exactly, and it's really great having the public involved and actually including them in our results. Something similar we're doing is actually working with the Forks telescope and the Las Cumbres network, and we're helping schools work with us to actually identify some of these systems and to look at their own data and characterize the systems we're looking at.
So if anyone wanted to get involved with this, would you say go to zooniverse.com, is that right?
Yeah, definitely. So go to Zooniverse and check out the SuperHorse project and help us identify variable stars.
That's brilliant. Thank you so much. So I've been Helen at RASNAM 2019. Check out our YouTube channel for more. Thank you.